Welcome back. I'm Gary Berg-Cross, and we have as a second section something on soil semantics. And the logic of the organization of these, that we'll start with a very broad idea of semantics, getting into things such as the semantic spectrum. We will start to drill down into work of the Semantic Harmonization Cluster, and Ruth will present some of the work from the cryosphere. Then Pier will give us an overview of the Envo and how it's been used within semantic harmonization, or cryo domain definitions. I will then drill down a little bit further and try to relate some aspects of soil within and see where they might fit within Envo. And then we will jump to presentation on Glossary ontology, and follow that by a very big glossary of soil semantic terms. Okay, with that, let's turn it over to the first presentation by Brandon.
Thanks, Gary. I just wanted to briefly talk about what a semantic resource is and some sort of core concepts, because I think they'll be useful for the rest of the slides. So when we talk about semantic resource, we talk about really it's any structure that's used to capture information necessary to help find, understand, and reuse data. This would be synonymous with a semantic artifact, semantic model, knowledge organization system, and so forth. It includes control vocabularies, data models, thesauri, taxonomies, classification, ontologies, property graphs, and so on, okay? So there's sort of three fundamental aspects. The first one is you make a statement. So in the sort of subject, predicate, object pattern, right? So sandy loam is a soil texture, water is wet, I am tired, whatever. That isn't super exciting, but if you have 100 billion of them in a store, in a graph store or a triple store, then you can start to ask some interesting questions, hopefully. The second part is on the right half of the slide. I just wanted to make a point that one of the reasons these are useful is because there is a computational component. So there's an underlying logic underneath most of the resources. So I'm just saying that the same statement that was on the left, sandy loam, is a type or a kind of soil texture. But when you build it on top of this logic, that means that the computer can make use of it in some way and find relationships and so forth. The bottom section is just, it sort of has to do with the semantic web and the idea that you might, all the terms that we might use in our statements are mapped to a URI. It's a uniform resource identifier. And that means that they're basically like, at web scale, they're a global unique ID. They are the globalist of unique IDs, okay? Next slide, please. So this is, it's a semantic spectrum with some other bits. Where the X and Y axes start is where we sort of start. And we have a very low level of semantics, where we have things like taxonomy. As we work our way up the graph, you have taxonomy, thesauri, conceptual model, and logical theory. And as you work your way up, you can do more things with those structures. There's an idea, it's called expressivity, which just means that you're able to describe more things more precisely, okay? So as you work your way up the graph, there's more vocabulary items available to you to describe either your data or your concepts or whatever. So on the lower left, we might have things like concept lists that they might not even have a URI because they'll be application specific. And then as you work your way up to the top level, where it's up near the upper right where it says logical theory, you might have more complex statements where your properties, as it says on there, there's transitivity properties, or in a simple example, you could have, it's a logical negation, or from a database perspective, a not. So if you have if you think in terms of sets, you can have the set of all things, all the types of sand and all the types of water. And you say, well, you can't have both. You can't be sand and water at the same time, right? So it's a bit absurd, but just to give you the idea. Along the bottom, then we have, it's called a forward instance. What do you use this for? So you're creating these models, and why are you using them? Are you just trying to, is it like an information retrieval situation? Or are you trying to, as you move to the right on that x-axis, are you looking for trying to model maybe more comprehensive domain knowledge, like in a soil science environment or some of the databases that we've seen in the earlier sessions? If you go to the next slide, I got to be close to time, Kathy. And this, I just wanted to show you as an example. This was an exercise where I tried to take many earth science ontologies and, well, semantic resources, and map them onto the spectrum. So if you want, you can have a look. The slides will be available. You'll see there's, in the sort of middle-ish, you'll see a lot of ML, that's markup languages. There's sort of a markup language lens, if you like. And then there's a whole bunch of other ontologies that, yeah, it gets into how you create them and what they're useful for, but that's the sort of layout. That's all I have.
Ruth is next.
Right. Okay, so I want to talk about the Federation of Earth Science Information Partners has a semantic community that has several clusters within it. One of them is the Semantic Harmonization Cluster. And this is sort of the process that cluster has sort of developed over time to deal with how to harmonize any of the resources, semantic resources that were just discussed, anything from glossaries all the way up to ontologies, and what the process should be. And this is a description of that process. You basically compile the resources you have into a list of what exists. And then you try and figure out what you're trying to achieve. In other words, you identify a scope and some targets. You assess the quality of the resources that you have and the concepts that are within them. Identify probably a subset of things that you're trying to harmonize. For example, top level terms from all of these different databases we were hearing about in the first half of this session. And then you do an analysis of those terms and those concepts, and that leads to some results, which you may need to update the targets that you're working on. And this all needs to be done in conjunction with not just domain experts, but also semantics and technology experts, so that you're bringing those two communities together to optimize the results, much like we heard the one project that was working with NCs to come up with a very generic data system. Next slide. And we started doing this work with the cryosphere, where I had already been funded by the Global Cryosphere Watch to look at 27 cryospheric glossaries with their 4,000 different entries, of which only roughly half of those were unique. And I do note that from those glossaries, there's a large number of permafrost related terms and a large number of landform terms, which this particular community might be interested in, since permafrost is really soil, and landforms usually are made of soil. Anyway, so that assessment that existed basically showed that there were about 400 terms across the cryospheric community that had where the meanings varied dramatically across the subdisciplines. And the process we used was exactly what I had described on the previous slide. Basically, we identified that we wanted to assess the GCW terms in the earth sciences. The two major semantic resources were the Global Change Master Directory, scientific variable keywords, and Envo, the environmental ontology. And so what we wanted to do was assess what was in the GCW and Envo and Suite, and basically bring all of those three things together, because that would help integrate all of the various things which used those existing resources. And so we did that, and you can just read about the results. I just wanted to point out that there are several kinds of issues that come up when you do that. I show you a couple of different terms: frost boil, degree of saturation, and extensive discontinuous permafrost, just to show that within a single community like cryospheric folks, there can be pretty good disagreement as to what some of these terms mean. And I think we saw that in the soil presentations earlier today. And I think I'm probably out of time. So yes, next.
Yeah.
Yeah, so I have more than 2 slides, but I should wrap it up in 2 minutes. So this is just a quick overview of Envo and what it does. And this picks up very much from Ruth's talk and also from Brandon's introduction too, certainly. So Envo is one of the ontologies we used for our cryosphere mapping, and it has some potential for soil too. So let's jump in. Let's try to jump in. Right. So the ontology here, as Brandon had shown, it's really getting towards knowledge representation. So it's a little bit more expressive. It has a little bit more richness of content so that machines can kind of understand what a term means and how it links and relates to other terms. So it's on the upper spectrum of the semantic ladder, as it were. So Envo, it's a community-driven ontology for representing environments. It interoperates with a few other ontologies in the OBO Foundry. We'll get into that, but particularly with the Sustainable Development Goals interface ontology that was co-developed by UN Environment and now which is being used in UNESCO IOC, UN Ocean Decade, but also a number of other sustainable development initiatives. So they work together quite closely within the OBO Foundry. And the OBO Foundry, it was an effort quite a long time ago now, but actually, well, not that long, to bring some sort of structure to a whole family of ontologies, primarily from biomedicine, but then going into planetary science with Envo, to try to make sure that they themselves are interoperable. Because having a term from an ontology or a vocabulary doesn't magically make your data interoperable with somebody else's, unless those resources themselves are making efforts to stay aligned and be interoperable. So that's where we are. So that's our mission, to build this robust semantic layer that allows this bridging of biosemantics, ecosemantics, the socioeconomic semantics, and geosemantics that are all kind of coming together. And as Ruth showed, working with domain experts to make sure that the knowledge we're representing is accurate, so that the technology implementation of that matters less and less, because we are still talking about the same thing in different flavors, but there it is. And then to try it out and make sure that it works on a technical level. So again, the QA/QC that Ruth spoke about. So Envo has collaborations with a number of other ontologies to make sure it's interoperable, from ESIP and Suite to agros or agronomy, some efforts with food science, from chemistry, from the gene ontology for biological processes, and several more. This is just a snapshot of some of those. But it's not more than just collaborations, it's also technical interoperability. So Envo actually imports large chunks from these and also exports chunks of its content to those ontologies, so we can weave together a language that a machine can process over and come to reasonable results using, so that it can be tested. So that means when you see something like a volcanic eruption, we take that string of what the thing is in the environment, which isn't so rich, connect it to an IRI, hops over to the web, and a machine will see a little graph about what's in there. So terms from Envo, which interoperate with terms from a chemical ontology called KEBI. So we know what the process has as output, and also with other ontologies like PATO for qualities and properties, to then express to a machine what kind of outputs it could have logically. And then you can come to some cool queries. That's where the importance of interoperability comes in, and that's why the harmonization is so important. As Ruth mentioned, we did this for the cryosphere vocabularies that you did, and built little subgraphs inside the ontology, formalizing the definitions, compacting them, and then adding sort of qualifications into the very messy realm of how humans talk to each other. We then, of course, map it out to other resources, including Suite, LTR vocabularies, permafrost in Wikipedia, and others as we come across them. We're getting better at it, so it's getting richer and richer, also linking to processes. And for soil, we have a hub. We have terms for soil from the FAO primarily. The soil term in Envo is used by a number of other ontologies in our operating space. These are the ones who have imported it. So it already has some coverage. There's more not reported by this tool, the OLS. And we have various links to what soil is, what it is, and 75 subclasses of soil currently, but that has not been harmonized. That's just coming from FAO and a few other cases. That's where we need soil semantic harmonization clusters or to help us then bridge the Australian classification with the US classification, et cetera, et cetera. And we're ready. Technologically, we're ready to do that and help you build the knowledge graphs you need. And then that's it.
Okay, back to the slides, I guess. So I'm going to follow up this view of Envo that was provided by Pier and Ruth's discussion of semantic harmonization, looking at soil in Envo a little bit more closely. Hopefully you can see most of this. For one thing, we have a classification of soil as a type of environmental material, and that is in the definition. We also, as Pier pointed out, have a URI or a link to this item in Envo. And if you look in the blue annotation box, or actually just below, you'll see the Wikipedia definition that was used initially to define soil. Envo captures a number of things about soil, including a number of soil types like farm soil and so forth. You can see that in the lower left-hand side. Next to that, sort of in the middle below, are the axioms that Envo has had for soil, which capture the essential definition that we have for the term. So it is a type of environmental material. It has some parts silt, it has some qualities, and it has a variety of parts. So this is an essential capture of some aspect of soil. It doesn't capture everything. So for example, soil horizons and profiles shown diagrammically over here are not really represented within this at this point. Next slide, please. So what I thought I would do with this slide, my second and last slide, is to take one term that Katie was interested in, field soil respiration, and look within Envo to see if we had something like that term. We didn't have that exact term, but we had something called ecosystem-wide aerobic respiration. And we see in here a little bit of what we know about that. So it is a hydrological process. That's not wrong, but it's incomplete in the sense that field soil respiration is a biological process, and some of that information was missing. So this slide also contains, and it looks a little bit small, at least on my screen here, some information. You see again the axioms in terms of parts, its subtype, and has input and has output. So those inputs and outputs are very interesting. You can see how the axioms are formed here. But if we include something like the biological process, we'd add more axioms. We should add things like the activity of soil organisms. And that takes us to something that Envo doesn't really have much detail on, but part of the OBO Foundry, the plant ontology, does have, as you see above. It includes a fair amount of information, and it would be a start. So that way, Pier mentioned that we would be linking Envo with other ontology to support it is reflected in this diagram. Okay, that does it for me. Let's turn on to glosses now.
Okay, I'm not quite sure how the audio is going to work on this, so we're going to maybe have some excitement here. I'm going to hit play.
Or we can hear something, but it's really faint. We can't make out the words, unfortunately.
You can't make out the words? Okay. I know there is a way to do this. All right, I'm gonna try this one more time.
Maybe Bar has an idea about how to do that.
I don't. I could, because it's on Kathy's computer. I don't know how to. Yeah, not sure how to mess with it. But
let me.
Oh, but Augustine just said advanced setting.
I am in screen shares. My apologies, folks. All right, I'm going to give a 30-second overview of Glossas and drop a link to the presentation itself, and folks can watch this offline if they are interested. So Glossas is designed to be a data, Glossa stands for Global Soil Information System, and it's designed to be a data interface to promote exchange between national and regional databases. It is designed to be Inspire compliant, so it is, oh hey, let's give that a try. I'm going to mute the audio here. Right, so one of the things that they've been focusing on is capturing codeless and properties thereof. So this is an example of the total nitrogen, which has some value associated with a unit that is associated with a layer and a horizon, and uses a procedure. So we were talking earlier about having observations and procedures or methodologies incorporated into a single data point, and this structure tries to capture some of that. And I'm clearly missing some very important features of the talk that you should very much go back and listen to. Right, so part of the challenge here is to aggregate the codeless to create those procedure references. And for example, texture fractionation can be defined at multiple cutoffs. So what it is for one location is not necessarily the same as another. And so you can take this texture cutoff and extrapolate it to more complex measurements like extractions, and you can start to see some of the challenges in trying to represent these procedures in a way that's interoperable and precise.
Also, everything in this example is annotation. The only thing that last line where it says in scheme, that's the only thing structural. Everything else is just the annotation for humans to look at the concept or look at the associated values. Sorry to jump in, Kathy.
No, thank you. So here are 2 links if you wanted to learn more. And Glossas also did provide a one-pager there.
I would just build on Brandon's comment that you can see from my examples also the fact that an ontology like Envo is rich. It has many types of information in there. So it has very, links, for example, but it also has comments and annotations, and it tells you, for example, about synonyms and where the definitions came from. So it's richly documented, and therefore becomes like a repository that a domain can leverage.
Right, and this ties more directly to an individual measurement or observation and sort of starts talking about tagging and annotating that information.
Yeah, but at least it gets it on the web. That's like half the battle, right? To get it on the web, And Envo is rich in some spots where we had expert input. In other spots, it's pretty empty, right? So it really depends on the community.
And talking about vocabularies, April, you said your computer just froze. Can you unmute? Do you wanna? You're next. You're wrapping us up. Apologies for the technical difficulties, everyone. All right. Okay. Then April, I think I am going to step in and give a really, oh, you can't unmute. I can unmute. How about now? I can ask you to unmute, but I can't unmute you directly, unfortunately.
Yeah, I tried.
Can
Oh,
you hear
go
me
for
now?
it. Yes, yes, we
Okay.
can.
Sorry, another technical glitch. And so I can't actually see the slide. I'm looking at the one that's on the slide deck. But yes, thank you so much for letting me speak about the glossary of soil science terms. The link is here. A lot of what you all were talking about earlier, I'm thinking in terms of what's missing in our glossary as opposed to what's there. But we do have a new updated glossary being published online this year. And it includes variables of interest like taxonomy, the various nomenclature used to describe soils, various methods, units, and how to convert them. What's really interesting about this glossary, I think, is that it also tells you the subdiscipline of soil science that might be interested in a particular term, and whether the term is obsolete or not, how it's best used, whether you shouldn't use it, things like that are kind of interesting from a cultural and language viewpoint. Next slide.
Mm-hmm.
So the glossary itself, it has been digitized, the current version, but the new one will be behind a membership paywall. But membership is not that expensive if you want to join, or what we're currently working on with ESIP and other groups is to think of ways to make this glossary more available and usable for other groups. We could definitely be looking at that. In my world, you really have to know a lot about the processes that you're interested in, because so many of the words aren't there. The glossary to me represents more things that are missing than what are present. And it's also interesting to see that there is a change in the language of terms that are the way things are described. So we need, one of our challenges is trying to come up with a good way to update this and make it a bigger, better resource for people. And I'm sorry about my computer. It's just so weird.
Thank you. All right. So we're going to end on clarifying questions to the presenters. And I'm going to, if nobody drops anything in the chat in the next minute, because we're a little tight on time, but I want to give people opportunity to ask questions for the recording. Mandy, is the K-12 glossary going to be behind a paywall too?
I'm not exactly sure how that's different. We do have a large set of resources for the K-12 that are really meant to be public facing. And so I can't imagine those would be behind a membership paywall.
Okay.
If that makes sense.
All right. On that note, I think we're going to stop recording. And I do think that so if Mandy could hit stop recording. Do we have